Hello, good evening, students. Welcome back. So, we have started a very important topic. Last time we have told you helium, neon, argon, krypton, xenon, and radon.
And read on.
These are noble gases, students. And we have told you some of the atomic and physical properties of the noble gas elements. And we told you that they are also called aerogens because they are present
In the air.
less than 1% in air,
Yeah.
and argon is the chief component which is obtained from air. We can get it from air. Helium and others, they are present under the earth and are also present in certain minerals which are radioactive, students, and also in the natural gas. These gases are important, as you have seen beautiful colored lights which are being used in advertising boards. Helium balloons, you are quite familiar with, students, and there are other reasons also, as these are gases and exist as monoatomic. And what we have told you, there are few questions which were asked, which we have discussed, student. But we
Yes,
are
sir.
saying that the noble gases, student, they have low boiling points.
Yes, sir.
Their boiling points are low.
Low.
The question was asked, why? Every time, students, we are doing inorganic chemistry, there are questions to be answered based on certain concepts. So we must be clear of what concepts, what property we are using. And at different stages, different properties are being used to answer the questions. So the boiling points will be decided by what, student? When I say, okay, boiling point, as soon as it comes in my mind that there are molecules in the liquid state, they are going to be they are going to convert into gaseous state. They have to leave the liquid state. There must be some intermolecular forces of attraction which we have to
Yes, sir.
create, students. And if those forces are weak, what will happen? Their boiling points will be
Volume will be
low.
low.
And in this case, you are so clear that they are existing as monoatomic
Monatomic. So they have weak dispersion forces.
and weak dispersion van der Waals forces. We had discussed about that. There are weak van der Waals
Dispersion forces.
dispersion forces, students. Okay. So every time you see that, we have to write little and go to the fundamental. What is the reason? That's the point. Nobody is asking you, students, to write more unnecessarily. But we must understand what is the things which we are talking of: atomic properties, physical properties. We are talking of sizes, ionization therapy, electron gain enthalpies, and the electron configuration. Everything will affect and will be reflected in their chemical reactions and properties. That's the idea which we are talking about. And that's how we are trying to learn, students, inorganic chemistry. Inorganic chemistry, you find it easy or difficult, student? Tell me now. You liking it?
Yes, sir.
So you have seen, if you see the book, oh, it looks very difficult. Structures are drawn, students.
Yes, sir.
How do we draw it? And where we also will learn them, learn them. I'm not saying mug them. I'm saying learn them. Once we learn them, then now we start appreciating that there is a chemistry. There are fundamental concepts behind everything, whether it's chemistry, physics, whatever you do, there is science behind everything. And that is the secret to be decoded, students, by us. With the help of students, I am trying my hard so that you can get the information and dive deep inside the concepts and to be able to decode each and every word of the books which have been written. So let us see what more we can talking about. Now we are saying, we already discussed their physical property, that they are these are gases, and now we are coming to the chemical properties. As we said that long we are it was not possible to prepare the compounds of the noble gases.
Yes, sir.
Why? Because they are stable.
They have stable outer electronic
Their
configuration.
configuration
So they
field, they are completely stable. Therefore, they have no reason to accept or lose electrons.
yes, sir.
So they are completely filled, completely satisfied, completely filled. ठीक है? For
Yes, sir.
example, helium you said is 1s2, and rest of the members you are saying ns2 np6. That is the and the valence shell is complete. Therefore, valence shell is completely filled. Hence, second, they have they are not interested. They are inert. That's what we are saying. Inert gases. Inert gases. Why they are inert? Student, I'm using the word inert. Inert gases. And their ionization enthalpy values high. Ionization enthalpy values high, and electron gain enthalpy. Student, what is the electron gain enthalpy? Electron gain enthalpy that are positive. You have to supply energy to add electron to them. Is it not that electrons will go and energy will be released?
Yes, sir.
So if such is the situation, why should they react? That is the point. They don't want to react. When something is not reacting, we have to force them to react. Then what we do? What is the story now? They are not interested. They are very satisfied. Now we are saying we will force them to react. Force them to react. We want to force the inert gases to react. But how will we force them, students? And if you don't have that much power, you have to have power to do that. Which elements will have power to do that? That is the question. Which elements will be able to do it? And we are aware of the chemistry. We are learning chemistry, students. You are aware what is happening in the chemistry. What do you think, student? Which elements will have that capacity or capability to force them to react?
Sir, which are the most electronegative elements?
All right.
The fluorine.
So, okay, we are saying that those elements which are highly oxidizing, strong oxidizing agents, students,
Okay.
which
Yes,
are
sir.
highly electronegative elements, as we are saying. So we are expecting the elements which are highly reactive or highly electronegative, strong oxidizing, like fluorine, oxygen. So we may expect that we will try to react them with these and force to form compounds. Interesting. The
Okay.
knowledge of chemistry will help us everywhere. You see, if we have knowledge, we can try the experiments. That is the story. And something happened amazing. 1962. You will see in the NCRT book they have written Neil Barlett. In the question, even his name has been given sometimes. Neil Barlett,
Okay.
so important is that. Then at the University of British Columbia, he found he was performing experiments and he reacted oxygen with PTF6, PTF6, hexafluoride of platinum, and he obtained a red compound. What he obtained a red compound, student. What is the red compound he was obtaining? He obtained a red compound, student, the formula of which was given like O2 plus PTF6 minus. So he was able to prepare this compound. This is a O2 plus PTF6. A compound is prepared, student. This is red in color. Interesting thing is that this is a molecular oxygen. O2 is a molecular oxygen, not I am not talking of atom. And he found that the first ionization enthalpy, student, is important question for exam also. First
Okay.
ionization enthalpy of molecular oxygen. Molecular oxygen is how much? 1175 kilojoule per mole. So the first
Okay.
ionization enthalpy of oxygen O2 is 1175 kilojoule per mole. Students, interesting that this is molecular oxygen. What is this, student? Molecular
Molecular oxygen.
oxygen. O2, this is not O. Not O. This is not the, I'm not writing the student, the ionization enthalpy of oxygen atom. I'm writing for O2 is a molecular oxygen. Okay.
Yes, sir.
And the idea struck his mind. As he was studying xenon, he find that the ionization enthalpy of xenon is 1170 kilojoule per mole. So these values are quite close. They are very close to each other. And therefore he thought, let me try, instead of reacting oxygen with PTF6, and let me try to react, student, what he wanted, xenon with PTF6. So he tried mixed xenon with PTF6, students, and he said that a compound has been formed which is red in color, and he gave the formula of the compound to be Xe plus PTF6 minus. This is the formula he has given, students. He gave this formula. So this was the first compound. This is the first compound, students, which has been prepared. I'm talking, this is the first
Okay.
compound which is prepared.
Okay.
All right. Some sound is coming from somewhere. Check it out. Now the
Yes, sir.
question is, xenon and platinum hexafluoride, they are reacting to form Xc plus PtF6 minus. And oxygen is forming, that compound is being formed by the oxygen, student.
O2
O2
plus PTF6 minus.
F6 is forming, student, O2 plus
With
PTF6.
minus. PTF6 minus.
Now let me tell you one thing which is not written in the NCERT book. Today, after more research work, it has been found actual formula of this compound is not this. Actual
Okay.
formula of the compound is not this, student, because it further reacts with PTF6.
Okay.
It further reacts with PTF6, and what we are getting is, the formula is not this, but the formula is XEF. This compound is XEF plus and Xe2. This is not Xe2. Let me write the exact formula. It reacts with, I'm saying, it's not going. Okay, yeah, try this. Just a minute. Okay, very important point. Very important point. This is not existing in NCERT book, students. What happened is that what we are saying that this XEPTF6 is the formula which is given in NCERT book. Nobody will make it wrong in the exam. But the story is that there is a more work which I was done to find that this further reacts with PTF6, and the product which you are getting is XEF plus, and you are getting PT2F11 minus. This is the formula. So
Okay.
I'm putting this plus on above. So the formula is now XEF plus PTF11 minus. This has been now confirmed by the studies which they have done. They have instruments to study spectroscopy and other type of things. They have been able to find the actual compound is not this, which was eradicated. This was the story. This was the beginning of the formation of the compounds. So in chemistry, what we are trying to do, students, that ionization enthalpy values are being used by the Barlett was used and it worked out. It worked out. Sometimes we try the experiment, they don't work out. So then it was very clear that xenon can form compounds with electronegative element, as I said, electronegative element. And the search and the work research started to react to the xenon with oxygen and fluorine compound. These two are going to be important compounds with which we will try to make compounds of xenon, students. Interesting thing is that till date, other elements are not forming compound. There is no compound of helium, neon, or argon. Only one, for krypton, only one compound is known. That is Kr of 2. Only one. This has been prepared. I am putting in this. Which compound has been prepared only? You know why we mention these things? In exam, they can ask such questions, student. Which compound of krypton is known? Or which other element forms compound? Only one compound is known, krypton difluoride. Other
Okay.
elements, nothing. No, they are not reacting. Not reacting. And xenon, once it started, they started. The conditions are to be very careful. You know, chemistry doesn't mean I write an equation, it is happening. There are temperatures, there are pressure, students. And those conditions will be mentioned when those scientists or chemists who are doing these reactions. In our course, we don't go into those high details. But wherever reactions are given, we are giving you temperature, pressure, catalyst, or whatever it is. Most of the cases for our course, we are giving you. Okay? And I'm trying to get you information more than what is in the NCERT book, because
Okay.
it's important that once we are studying a subject, we must study it thoroughly. Some amount of deep study is required. It is not that whatever is written is a line. Let us go and study that. That is my point. So up to now, student, we have answered few questions. First question was, which was been asked in the paper many times. Why the noble gases do not form compounds or are inert? You have answered that question.
Yes, sir.
What grounds you have given? We have given two reasons: stable, completely filled valence shell configuration, and high ionization
Ionization
enthalpy.
enthalpy and more positive electron gain enthalpy.
Okay. Then you said ki, okay, we will make attempts to prepare the compound. Second question: which elements will be able to form compounds with inert gas, if at all possible? Then you have answered highly oxidizing
Oxidizing and
or strongly
electronegative
electronegative
reactions.
elements. Strongly electronegative. All the questions basically atomic size, ionization, electron gain enthalpy, electronegativity, covalent one, ionic one, oxidation state. All this we are using. And if you don't know how to calculate oxidation number and all that, then what reactions we are doing? Very difficult. That is my point. You got it? Why we
Yes,
are
sir.
putting so much effort? Why I am
Yes, sir.
putting so much effort to it? I am putting extra efforts for all those who am teaching. And I have to work very hard for this. It's not easy. That's why I said try to share my videos and subscribe for other students. And let them also take the benefit, student. Here our hard work is important, and the more students we interact, the better we become, because we learn from the students a lot. Got my point? So we learn from you people, and once we are working hard, we want that more and more children should be able to see what we are talking about.
Yes, sir.
Okay, so you should be able to pass our videos to your friends so that they can also see what is your performance. Your performance improves when you keep on interacting and answering questions. As you will think, you will improve. If you won't think, you won't improve. That is the point always. Now the question is, the compounds of fluorine are there, and question is definite. I'm telling you. You will see in the board paper question. I'm telling you answer. I'm telling you that these questions are there. You can always see them. Okay. In every competition, you will see them.
Okay.
Okay, student. Your life is will be decided by the attention you will put. Attention you will put. So we have to
Yes, sir.
concentrate and focus. I'm saying xenon and fluid. Every word I write, you see, I give some time to that. Student, I don't hurry up. I give time to that. I give attention. Even my mind needs attention to understand what I'm talking about. How do I explain these things to students? Now there are fluorides of the xenon, because fluorine is the most electronegative element. Okay, good. You are a scientist. You said, sir, I will See, fluorine is the most electronegative. I will try to prepare compounds with fluorine, and it will be able to get it. Which compounds you will prepare them? I said, okay. The fluorides you have seen, students, there many times they have asked question that you are reacting xenon and fluorine. Okay?
Yes,
And
sir.
you are getting different fluorides. Which fluorides you are getting, students? What you are making? You are reacting this. What you have got, student? What you have got is XeF2. Okay? This is a
Okay.
solid.
Okay.
This is a difluoride. Difluoride. Then you are saying, student, you have got XeF4
F4.
solid. Then you are getting XeF6 solid.
Okay.
So what are the oxidation states of the xenon, students, in this?
Sir, it would be X minus 2 plus 2
Plus 2. What is oxidation state of xenon in this, students?
plus 4
Okay, excellent. What is this?
plus 6.
So you are so fast now, you understood that so well. Okay. So, okay, plus 2, plus 4, plus 6. There are three important fluoride, student. It is absolutely clear that if I will write the reaction, student, I have to mix xenon and fluorine, and then temperatures will be required. But the question is how much amounts are required, that is important. Imagine if it is F2, then you need less amount of F2. F4 means you need more amount of fluorine, and F6 will mean more amount of fluorine.
Yes, sir.
So this is important. So a question has been asked, give the reaction for the preparation of XeF6. So that we already know you are mixing what you are mixing. You are saying you are mixing Xe. Xe is a gas, student. Fluorine is a gas, student, and you are getting XeF2. Temperature is a 673 Kelvin and 1 bar.
Okay.
Now the ratio is important. Here I am saying this is in excess. When
Okay.
xenon is in excess, student, you will get xenon difluoride. Now the second thing I am saying, you have xenon. Xenon is a gas, and you have F2. Now the temperature goes 200 more. It becomes 873 Kelvin, and the pressure also increases, student. Now the fluorine should be more. The ratio is, this is 1 volume, this is 5 volume. So here you see 1 is to 5. We have come to 1 is to 5, student. 1 is to 5. Further, you are saying react to this with fluorine. So you have to balance it. You will balance it. You have to.
Okay. 2F2 and
And
this
here
is
you are getting this. And
3F2.
here
Okay.
the temperature is 573 Kelvin and pressure 60 to 70. As I say, high
Okay.
pressure.
High pressure.
So pressure 1760 to 70. And ratio here you are getting 20 to 1. So volume of fluorine 20. 1, 5, 5 for the 20. 1, 5, 5 for the 20.
4.
It's a
Okay.
way to, I mean, understand and remember, for example, ratio. Basically, this is 1 is to 2, 1 is to 2. Then basically, one, if I say excess of this, then 1, 5, 20. 1, 5, 20. So what has happened? The ratio you can see 1, 5, 20.
Yes,
60,
sir.
70.
Yes, sir.
So this is a way to remember, students. The ratio of this is important. Question has been asked on this. Question has been asked on the preparation of xenon fluorides. Preparation of xenon fluoride. Such questions will be given and asked. Okay.
Yes, sir.
Okay. What is the ratio? 1, 5, 20.
1520.
Temperature, we have to be careful because such questions will be there in exam. Further important thing. Okay. We have to do research for every question. The XeF6 can also be prepared. Student, these reactions are given in the paper. Sometimes they will ask you complete the reaction, complete the reaction. What they are doing, देखो, If I start with XeF4, this is plus 4, I have to go to plus 6. When I go XeF,
+6.
XeF6 means you are going from plus 4 to plus 6, and there is a compound O2F2. Now I told you when we were studying the group 16 elements, I told you something about this. What I told you about O2F2? Tell me.
O2F2.
Even for the fluorine, we told you something very important about this compound, student. They are very good fluorinating agents.
Fluorinating agents, yes, sir.
Okay, okay, you got it. Remember. Now, how do I remember this thing? Fluorinating agents, students. Here you need fluorine. Now you need two more fluorine. Two more fluorine. What I'm trying to remember. In the exam, how do I get it? I can't cram it. I will use a compound which could be a good fluorinating agent. Fluorinating agent. And we know that this compound provides fluorine very easily. And what will happen if F2 goes here? Now what is left then? What is left for us? O2?
O2.
So the reaction is complete. And this reaction has been asked in the paper. They
Okay.
have asked the reaction XeF4 dash XeF6 dash to complete the reaction. Paper, you know how they give it. The reactions are important. This chapter has got questions for you in the paper. I'm telling you, in P block. They are very special compounds, and they become very important questions. Students and children try to just ignore it. Now, another interesting thing, students. What is happening now? The important point is that these the temperature is also mentioned at 143 Kelvin. 143 Kelvin. So the most important reactions are here, students, which we are talking that they are basically crystalline solids and sublime, and they are also powerful fluorinating agents. But the hydrolysis reaction is the most important. Hydrolysis, student, now. Here question will come in the paper. Hydrolysis. This compound, student, that reaction will come. One of the reaction is going to come.
Okay.
XeF2, XeF4, and FeF6. They will react with water and get hydrolyzed. Now the question is what compounds are going to be formed? What compounds are going to be formed? So how do we get these answers now? That is our point, student. We have to remember what will happen. So let me say that I have XE student. I will be
Yes, sir.
doing the hydrolysis. Hydrolysis. I have to work it out and find some method so that there is something easy to explain to you so that we don't forget in the paper. Don't forget in the paper. Now, how do we do that? XE first. Let me take when I'm taking XeF6. I'm reacting with water. I am putting excess here. What I'm putting excess means there will be more water. And what happens, student? What happens in this case? How do I complete the reaction? One thing is that they are going to form an oxide, which I am saying XeO3. XeO3. I will try to find out how everything is happening because the water looks like H plus and OH minus. Okay? And this you
Yes,
are
sir.
saying xenon is in plus 6 oxidation state and you have 6F minus fluorine. Okay? This is the situation here. I mean, this we are not writing in the exam. This we are just trying to see how the products can be obtained.
Okay.
XeO3. Now,
Okay.
in the water, what else you have? You are saying XeO3, student, XeO3. So there will be water. This O oxygen will go to the XeO3, and there is a H plus and F minus.
F
What they will
minus.
form?
HF.
HF. F minus and H plus, very favorite for us. And what is happening beyond that? There is a formation of Xe, and there will be more oxygen here present, more oxygen. There are only three here. There are only three here because if we will try to balance, there are six fluorine. There are six HF. There are six HF students in this case. But this is not balanced yet. This is not balanced. If I see here, XeO3 is being formed, HF is being formed, and I'm saying xenon and oxygen. Oxygen. Now we have to balance this equation. Actually, the important point is this is in plus 6. What is the oxidation state of xenon here, students?
In XeO3,
Uh,
it will be X minus uh, plus 6.
Same.
Plus 6. It would not change.
The question is just to for our memory part. If this
Okay.
fluoride is in the highest oxidation state, the xenon oxide is also in its highest oxidation.
Highest oxidation
So
state.
the formula becomes XeO3. We know that oxide will be formed, HF will be formed, HF will be formed as we have mentioned here. This because hydrogen and fluorine will react to form HF, and then oxygen will be formed, and there is a xenon also which is formed. Xenon, when I write it is a zero oxidation state, student, zero oxidation state. So xenon is shifted from plus 6 to 0, plus 6
Yes, sir.
to 0. What has happened to xenon?
It has reduced to 0, plus 6 to 0.
Because it is the highest oxidation state, plus 6 is coming to the 0, it is being reduced, therefore it is acting as oxidizing agent. That's why you
Yes,
can say
oxidizing.
you are getting oxide and oxygen. Oxide and
Okay.
oxygen. Now balancing situation 12H2O 6, and how much will be this? You have XeO3. You will have how many XeO3 student in this? Uh, this is you have 2 XeO3. If you have 2 XeO3, then you will have 4 here and 3O2 and 24 HF. So this is the equation for the hydrolysis. We have written it here. We have written it here. Now, interesting thing is this: you have got XeF6. This is a important reaction, very important for the exam. I'm telling you. One of the reaction will be given in the paper. Every year they are giving because students are not able to do it. Students are not able to do it. Students, they don't are unable to do it. Now, what happens? This is if the water is less, if the amount of water is less, this water was large. Okay? And
Yes,
if
sir.
you have less amount of water, then the reaction is XeF6 3H2. Here I mentioned excess, that's the reason. This goes in the highest oxidation state, student. Again, XeO3. And what is left then after this XeO3? 6 hydrogen and 6 fluorine.
Yes, sir.
So how much will be that? HF is always there. So you are getting an oxide and hydrogen fluoride and hydrogen fluoride. If you use very large amount of water, you are getting XeO3. HF you are always getting, you are getting oxygen and xenon also. And xenon also, student. So this is one reaction. Number 2 reaction. And third reaction, if I have xenon tetrafluoride, student, then what will happen? That will also be hydrolyzed. That will also be hydrolyzed, students. And partial hydrolysis, this is a complete hydrolysis, and partial hydrolysis also takes place in this case. Partial hydrolysis also takes place in this case. So did I made it right or something is wrong? Fluorine, how much is this? 24. 60. This fluorine is becoming 24 more. Actually, this is XEF4. This is XEF4 students. XEF4.
Okay.
XEF4.
Okay.
That is why there should be 24. Okay. This is a hydrolysis of XEF4. XEF4 gives XeO3, HF, xenon, and 3 oxygen. 3 oxygen. And this is the hydrolysis of XEF6. XEF6 is giving me highest oxidation state, highest oxidation state of uh, this. This was not, this was plus 4. Plus 4. Interesting thing about this reaction is important. I will tell you what is important. We have done some mistake here. Okay. This is plus 4 to plus 6 and plus 4 to plus 0 also. This reaction. See that xenon has been oxidized and xenon has been reduced.
Reduced.
In which XeF4 case. So what do you call this type of reaction? We already
It
know.
is a redox reaction
All reactions are redox.
and
All reactions.
disproportionation and
Disproportionation.
disproportionation.
Disproportionation. Disproportionation reaction. This is an example of disproportionation reaction. These reactions are very important in the exam. Which fluoride of xenon undergo disproportionation, that is XeF4. Because here you are getting xenon oxidized as well as xenon plus 4
On reduced.
reduced. These reactions become very important for exam. Disproportionation is a favorite reaction for examiners. They ask many times. So this is our XeF4 students hydrolyzed to give a XeO3 example of disproportionation reaction. Example of the disproportionation reaction. Plus 4 goes to plus 6 and then plus 4 is also going to 0 oxidation state. And if I react, this was the case. If I react xenon hexafluoride with water, no problem. Now here it is in plus 6 oxidation state. You are getting an oxide also in plus 6 oxidation. See, xenon plus 6 to plus 6. What has happened? Xenon is in plus 6 and also in plus 6 here.
Plus 6 here.
Therefore, do you think it is a redox reaction?
No, sir.
That one question becomes another question. That there is a
Okay.
there is a fluoride of xenon which is hydrolyzed, but it is not a redox reaction. It is not a redox reaction because the oxidation state becomes same. And oxide we have to write. I will write the oxide of the highest state. This is the fluoride of the highest state, oxide of the highest state, and then what is left is H and F. No problem. This is easy to remember.
Yes, sir.
Hexafluoride, if I asked in the paper with water, you will get XeO3 and HF. No problem. Both are in plus 6 oxidation state. So XeF4 and XeO3. And what is happening if I take student XeF2? I am saying XeF2. This all reactions are important. One, it is hydrolyzed with water. It is hydrolyzed with water. What you are getting XeF2? You are getting student Xe plus HF plus oxygen. Plus oxygen. Balancing is to be done, student. So if I have 2H2O, 2H2O, and this xenon fluoride was a solid, 2XeF2, 2H2O. This is our liquid, this is our solid, and you are getting xenon. Xenon is a gas. HF is aqueous. Oxygen is a gas. So you are getting XeF2 hydrolysis gives what? This is in which oxidation state? Plus 2.
Yes, sir.
This
Plus
is
2.
0. This is 0.
Yes.
So plus 2 to 0 means what?
Reduced.
Reduced. Therefore, it has oxidized the water. Water is oxidized to oxygen. You see, water is, what is water? H plus and OH minus. So water has been oxidized to oxygen gas. And Of course, H and F, whatever are remaining, they will form HF. H and F will form what? HF. So what is the balancing? How many are there? Four. Four HF. Interesting thing is coming. What interesting thing is coming? If I see the product of F6 and F2, ठीक है?
Yes, sir.
How do I go to the product of HCF4 now? One catch here. One catch here, student. And what I'm saying that you see the hydrolysis of XCF2 and XXF2 and XEF6. What are the products on the right side? Xenon, HF, oxygen, XCO3, HF. And what are the products of XCF4, student? Just one.
XeF4 is XeO3, then
Hmm.
XeO3, then xenon, HF, and O2.
Very important point. Now my all the three reactions become easy to understand and memory part I'm reducing. Dekho, listen to me. If I add these two, if I add these products, what products I will get? This has xenon, this has xenon, this has oxygen, this has oxygen, this has HF, this has HF, this has XCO3, this has XCO3. I got my point. If I remember these two reactions,
Okay.
XEF6 is easy to remember.
Yes, sir.
How I'm giving one more hint because this question is important. The students are doing mistake, as I also did. Question could be asked. Let me tell you what I'm trying to say. Students, because this point is very important. This will solve our difficulty in because this question is very important for them. Hydrolysis of xenon-fluoride is a very, very important question, students. And we must have some trick to do it. What is the trick? That I'm trying to do some research on this one. Let us do some work on it. Okay, first I am writing X E F6. ठीक है?
Yes, sir.
I am writing H2O. ठीक है? Hydrolysis. This is in +6. I am going
Yes,
to
sir.
oxide, which is +6. Then fluorine and H, what will they form? HF.
HF.
HF. Now the question is to balance it, student. How many H and how many F? These are 6 fluorine. There are 6 fluorine. So how many HF should be there? 6. If there are 6, then how many water should be there, student? 6, 3, 3. Is it balanced now?
Yes, sir.
Equation 1. And now I'm writing for XeF2 reacts with water. Reacts with water. ठीक है? You are getting xenon, and water. This water is what is happening to the water, student? It is being oxidized to the oxygen, and HF will always be there
Yes, sir.
because you have F minus,
F
and then
minus and H plus.
F minus and H plus. So what is, how do I balance, student, this equation? You have H2O and HF, oxygen, O2. This is O2, so clear. This has to be 2. O2, you want O2. Then this becomes 4 because 4H, and then this becomes 2. ठीक है? This becomes 2. बैलेंस हो गया?
Yes, sir.
बैलेंस हो गया. याद हो गया?
यस सर।
अच्छा,
ओके।
ये सॉल्व हो गया, कोई बात नहीं, इक्वेशन 2 बना लिया। अब थर्ड इक्वेशन मैं कैसे बनाऊंगा Hc4 का, अब मुझे याद करने का जरूरत नहीं है स्टूडेंट। अब ये रिएक्ट कर रहा है H2O के साथ, ठीक है, HCl4
यस
इज
सर।
गोइंग टू रिएक्ट विद वाटर स्टूडेंट्स। अब ये दोनों प्रोडक्ट सारे आने हैं इसमें, ये दिस भी, तो क्या क्या बन रहा है टेल मी। XCO3
XeO3,
भी बना, और क्या बना,
HF,
HF तो
HF,
है ही है,
O2
और ये जिनोन भी आ गया।
and Xe, O2 and Xe. Yes sir.
समटाइम्स ना देख से ये छोड़ दिया बस, अब ब्लैंक और फिल करवा दिया,
Okay.
so balancing is not important there. It is not necessary that I balance the equation, then I should know what are the products. He is asking
Yes sir.
give the product name, this question is given many times in the paper. Now अब इसको बैलेंस कर लो, कोई बात नहीं। तो जो भी बैलेंसिंग की स्टेट है, यहाँ पे एक्सेस मैंने लिखा था वाटर, तो ये 12 था और ये 6 है, और फिर इसको बैलेंस कर लो, ये 2 है, तो एच एफ कितना आया था, वो आया था 24, 12 टू 24 आया था, तो जिनोन 4 बचा था स्टूडेंट, और ये 3 तो इस तरह से ये इक्वेशन मैंने कहाँ से बनाई, ये फर्स्ट और सेकंड से बनाई, ठीक है।
Yes sir.
अब ये क्वेश्चन आया था, क्वेश्चन क्या था, डज XeF6 ए रिडॉक्स रिएक्शन, ये क्वेश्चन पेपर में आ गया स्टूडेंट। अब आपने आंसर करना है, क्या ये रिडॉक्स रिएक्शन है स्टूडेंट।
No sir. Hydrolysis of XeF6 is not a redox reaction क्योंकि जो XeF6 की हाइड्रोलिसिस होती है तो XeO3 बनता है और HF बनता है। तो XeO3 में जो ऑक्सीडेशन स्टेट है Xe का वो +6 होता है और XeF6 में भी +6 होता है, तो ऑक्सीडेशन स्टेट चेंज नहीं होता।
तो यू आर सेइंग oxidation state from +6 to +6, therefore it is answer not a redox reaction, मैंने ये लिखा पेपर में, ये शो कर दिया, नॉट ए रिडॉक्स, हो गया आंसर, ठीक है।
यस सर।
मुझे आई डोंट हैव टू राइट मच, बस इट्स ओवर,
ओके।
दैट इज क्लियर। दिस क्वेश्चन हैज बीन आस्क्ड, सो वी आर गिविंग दैट टू यू आल्सो। नाउ देखो यहाँ पर हम बहुत टाइम लिया, क्यों लिया, यहाँ पे क्वेश्चन है पेपर में, देख लेना मिलेगा आपको। एक तो प्रेपरेशन ऑफ फ्लोराइड्स ऑफ जिनोन, रेशो क्या लिया है, 155 टाइम द 420। दूसरा हमने क्या बताया कि आपके पास है फ्लोराइड्स, हाइड्रोलिसिस बताओ, प्रोडक्ट्स प्रोडक्ट्स, तो आपने क्या याद किया, Fe6 का, XeF6 और XeF2 का। 6 को तो मैं बहुत आसान था, ऑक्साइड बना दिया जिसका ऑक्सीडेशन स्टेट सेम था, और HF तो बनना ही है सबने, ठीक है। और जहां पे ऑक्सीजन बन रही है तो बनने दो, क्योंकि ऑक्सीडेशन जब होगी XeF2 ऑक्सीडाइजिंग एजेंट एक्ट कर रहा है तो वो बनाएगा। अब इसमें यह भी एक क्वेश्चन है, ये क्वेश्चन 1 था, क्वेश्चन 2 विच इज अ डिस्प्रपोर्शनेशन रिएक्शन। जो डिस्प्रपोर्शनेशन है उस पे एक क्वेश्चन हर साल होता है, डिस्प्रपोर्शनेशन, स्टूडेंट यू आर अवेयर ऑफ इट, इट्स वेरी इंपॉर्टेंट कांसेप्ट।
ओके।
डिस्प्रपोर्शनेशन रिएक्शन, तो वो भी आपने फाइंड कर लिया कौन से में हो रही है। अंडरस्टूड है, जिसमें XeO3 भी बना और XeO बना, तो उसमें होनी है।
यस सर।
तो यहाँ पे हो रही है, देख रहे हो, ये +4 से कहाँ गया, +6 में, और ये 0 भी है है ना,
यस
और
सर।
6 और 0, तो ये डिस्प्रपोर्शनेशन है ये वाला, ठीक है।
यस सर।
तो यहाँ पे हमने आइडेंटिफाई कर लिया। अब देखो कि आपने ये कहा कि जो इनर्ट गैस है जी, ये तो रिएक्ट नहीं करते, आप जो
यस सर।
कंपाउंड बनाने की है, तो आपने कहा या तो ऑक्सीजन या फ्लोरीन, तो फ्लोराइड्स के बना दिए। अब ऐसे भी कंपाउंड होंगे जिनमें ऑक्सीजन और फ्लोरीन दोनों हो सकती है, ऑक्सीफ्लोराइड्स। तो यहाँ पर आप देख रहे हो, ये सारी कंप्लीट हाइड्रोलिसिस की थी मैंने, तो पार्शियल हाइड्रोलिसिस के प्रोडक्ट्स भी पूछे जा सकते हैं। देखो यहाँ पे पार्शियल हाइड्रोलिसिस हो रही है स्टूडेंट, वहां पे मैंने मेंशन किया एक्सेस। देखो यहाँ पर हमने ये एक्सेस वाटर, ये वाटर में चल रहे हैं, कंप्लीट हाइड्रोलिसिस हो रही है। अब मैं कह रहा हूँ स्टूडेंट्स, क्या कह रहा हूँ कि पार्शियल हाइड्रोलिसिस की बात कर रहा हूँ। पार्शियल हाइड्रोलिसिस में क्या होगा कि ये ऑक्सीफ्लोराइड्स बनाएंगे। क्या बनाएंगे? ऑक्सीफ्लोराइड्स।
ऑक्सीफ्लोराइड्स।
तो ये भी इंपॉर्टेंट है कि पार्शियल हाइड्रोलिसिस ऑफ XeF2, उसने एग्जाम में पूछ लिया, पार्शियल हाइड्रोलिसिस ऑफ XeF2 राइट द रिएक्शन। तो XeF2
यस सर।
H2O के साथ रिएक्ट किया, तो अब क्या करना है तुमने? अब देखो कि इस एक ऑक्सीजन है यहाँ पर, ये अंदर आ गई और HF बनना है, HF बनना है हमेशा। HF क्या बनना है हमेशा? तो HF बाहर आ गया, दो HF है, दो H प्लस है इसमें, दो HF बाहर आ गए, तो XeOF4 बन गया। क्या बन गया? तो ये रिएक्शन दिख रही है तुम्हें?
ओके।
अरे कैसे बनाई है मैंने देखो पार्शियल हाइड्रोलिसिस की बात कर रहा हूँ मैं स्टूडेंट, पार्शियल हाइड्रोलिसिस कर रहा हूँ। पार्शियल हाइड्रोलिसिस में पूरे ऑक्साइड नहीं बनेंगे, XeO3 नहीं बनेगा, तो ऑक्सीफ्लोराइड बनेगा। ऑक्सीफ्लोराइड बनेंगे तो क्या बनेंगे? अगर मैंने XeF6 को लिखा स्टूडेंट और आपने कहा पार्शियल हाइड्रोलिसिस दिखाओ, तो बताओ कि यहाँ पर दो H हैं, तो दो H दो फ्लोरीन ले जाएगा, तो 2HF तो चले गया। अब क्या बचा फिर? Xe बचा है,
एक्सी
यहाँ पे एक ऑक्सीजन है और फ्लोरीन हाउ मच? 4। हो गया पूरा
4। ओके।
रिएक्शन, हो गया।
ओके सर। यस सर।
और अगर मैंने यहाँ पे 2H2O ले लिया, XeF6 है ये हमारे पास, और 2H2O ले लिया स्टूडेंट, तो अब क्या बनने वाला है? अब क्या बनने वाला है? तो यहाँ पे
इसमें
दो तो
एक्स
चार
ई
हाइड्रोजन हो गई, तो 4HF तो है ही है।
4HF।
अब क्या बचा फिर इसके पास?
XeO2
दो ऑक्सीजन
और
बचे,
फिर F2।
F2।
2 फ्लोरीन हो जाएंगे। यस सर।
तो इस तरह से स्टूडेंट्स हमारे पास ये कंपाउंड बने हैं, इन्हें बोलते हैं ऑक्सीफ्लोराइड्स।
ओके।
तो यहाँ पर जो हमने मेन चीज आपको शो की है स्टूडेंट, कि ये बहुत इंपॉर्टेंट है कंपाउंड्स, जिनॉन के कंपाउंड विद फ्लोरीन, दे आर वेरी इंपॉर्टेंट स्टूडेंट्स, एंड क्वेश्चन विल बी आस्क्ड on this. And now the question was how to write them in the, how to remember them, because there is some problem in write. There are three fluorides, XeF2, XeF4, FS. Anyone can be asked. So how do we do them? HF बने, ऑक्साइड्स बने, जिनॉन बना, और ऑक्सीजन गैस, तो प्रोडक्ट्स हमारे ये रहे। और कोई भी एग्जाम में क्वेश्चन दिया जाता है और उसमें वो बोलता है कंप्लीट करिए इनको, तो हमें लिखना पड़ेगा कौन से प्रोडक्ट उसने छोड़े हैं, हमें बनाने हैं। So I hope we have finished one part of this, and we will continue with more important structures of fluorides of xenon, which is again a new topic in the next class. And I hope you have noted down everything.
यस सर।
Then we'll meet you in our next class. Okay, sir. Students, good night.
ओके, थैंक यू सर।
Okay.